So what we're going to do in this video is cover the last 4 practice problems from lesson 7.1. If you were working through the Desmos activity and doing these and ran into some trouble, these are those 4 questions. So I'll go ahead and put the solutions into this video. The very first one that we're going to do here is actually the 4th question in the Desmos activity, and it talks about sterling silver. So sterling silver is a product that is made up of mostly silver, but also a little bit of copper mixed in. So you can't think of sterling silver as being pure silver because it's got 3 parts copper when there are 37 parts silver. So this ratio is showing you the proportional mixture of this thing to this thing. So don't think of this as being an amount. It's a percentage of the total, or a portion of the total. So if you do want to think of this as being, I don't know, pounds, go ahead. You could say if there are 37 pounds of silver, then there would have to be 3 pounds of copper. And so what you should think about this then as is a 40-pound sample, right? Because 37 of its parts are made of silver and the other 3 parts are made of copper. So this is a 40-pound sample with a ratio of 37 to 3, silver to copper. So what we're dealing with here is the mass of a piece of sterling silver measured in grams. Okay, so 600 grams of silver, or of sterling silver, is what we are working with. Now, if the relationship is the same, which it is, it's still sterling silver, 37 parts silver, 3 parts copper, then how much of that 600 gram sample is actual pure silver? And so the way to build this is actually to, I think we should probably use fractions here, be a little bit more efficient, and we'll represent this first of all just in terms of let's say a 40-gram sample. So if I'm comparing the amount of silver to the amount of copper in the sample, then I could represent this as 37 to 3. But that's not the useful ratio to use here. The ratio I want to use is the ratio of silver to total, the total mass of the silver, right? So if there is 37, or if there are 37 grams of silver, based on what we know, that would represent a 40-gram sample of sterling silver, right? That's this information here represented 2 different ways. This is the way here that's more useful, because now that I'm comparing the amount of pure silver to the amount of sterling silver that exists, I can do the same thing with this 600-gram sample, and I can say, well then, how much silver would exist if there were 600 grams of sterling silver? And this is where I do my algebra here to try to solve for x. So if I multiply by 600 on both sides, I end up with 600 times 37 over 40 on the left, and when I put that into a calculator, I end up with 555 grams. So in a 600-gram sample, 555 of those grams are pure silver. All right, let's take a look at question 5. Selena is taking a 90-minute test that contains 50 multiple choice questions and 30 true or false questions. And I'm just going to stop there for a minute and write down all of that information in one ratio. But then she completes 48 of the questions, and it takes her 50 minutes to do that. So now it's 50 minutes later, and she only has 32 questions left to complete. So this would be great if they said, how many minutes per question does she have left on average? I could just divide 40 by 32 and I would be done. That's how many minutes per question. But they don't say minutes per question. They say seconds per question, which means we're going to have to do another little conversion here off to the side. So when I compare seconds to minutes, I know that that relationship is 60 seconds per every 1 minute. And here, I'm dealing with 40 minutes, so how many seconds is that going to be? So that's going to end up being 2,400 seconds. So I'll go ahead and make a substitution there and say that this is equivalent to 2,400 seconds per 32 questions. These are the same thing, not because these numbers are the same, but because when I changed the number, I also changed what that number represented, or the unit of measure there. So these are the same proportion using different units. And now since I have the seconds per question ratio, I can do that division there. I could use a calculator, do 2400 divided by 32, and I'm going to end up with 75 seconds per question. Number 6. Okay, many ways to defrost a turkey. One way is to let the turkey thaw slowly in the refrigerator at a thaw rate of about 4 pounds per day. So let's record that information. Another way is to submerge the turkey in cold water, which thaws at a rate of 1 pound per 30 minutes. Approximately how many more ounces of turkey, that's a problem, can the cold water method thaw in 2 hours? Ooh, that's another problem. Than the refrigerator method. And they tell us the conversion rate for pounds to ounces, so that's nice. We're going to have to know the conversion rate between hours and days and minutes and hours as well, because we've got a lot of converting we need to do here. So the ultimate goal is to be able to represent these both in terms of ounces per hour, not in terms of pounds per day or pounds per minute. I need ounces per hour. So I'm going to have to do some converting off to the side to figure out what that's going to look like. Let's start off with the refrigerator method, and I'm just going to convert days to hours. Now, many of you probably can do this conversion in your head. But remember, we know that the number of, I'm actually going to call it hours per day. So in terms of hours per day, I know that there are 24 hours in one day, and here I actually have 1 day, so I'm solving for x. That ends up being 24. Pretty simple conversion there. So I still have 4 pounds, but now it's 4 pounds per 24 hours, which is nice because I do need my final answer to be in hours. Let's do the same thing here with the cold water method in terms of time. But this time I need to convert hours to minutes. And I know that in 1 hour there are 60 minutes. So how many hours does 30 minutes represent? And in this case, I'm just going to multiply by 30 on both sides. I end up with 30/60ths, which reduces to 1/2. So you can write that a number of ways here, but that means I can rewrite this as 1 pound per half hour. All right, so we've done the time conversion. Now we need to do the conversion for the ounces of turkey that exist. And they've told us already that the conversion rate between pounds and ounces is 16 ounces per 1 pound. So here I'm trying to figure out how many ounces would 4 pounds be. That's a quick multiplication there. So I can rewrite this top ratio then as 64 ounces per 24 hours. And the bottom one, you could do the exact same way, but remember, 1 pound is 16 ounces, so that's a pretty quick substitution there. Okay, now we're really close. The only thing is, we want to know how many more ounces of turkey the cold water method can thaw in 2 hours, so there is one more conversion we have to do. We not only need these to be in ounces per hour, but we need it to be in ounces per 2 hours. So one final conversion for each of these. So what I'm going to do here then is figure out how many ounces that would be in 2 hours, and figure out how many ounces that would be in 2 hours. And I'll do those at the same time here. So now we're in good shape. We know exactly what this is going to end up being in terms of ounces per 2 hours. I just have to do this division here. So 128 divided by 24 gives me approximately 5.3. So I'll say 5.3 repeating. And 32 divided by 1/2 gives me 64. So this is how many ounces will thaw in 2 hours using each of these methods. Now, if I want to know how many more this one here gives me versus how many that gives me, I'll just subtract the two. And 64 minus 5.3 repeating ends up giving me approximately, because we want to the nearest whole ounce, which it doesn't say here, but it does say in the Desmos activity, approximately 59 ounces more. All right, last one here. I'm going to try to move quickly because it's getting long. So the thing about this one is really just that you need to make sure you give your answer in terms of mini muffins compared to jumbo muffins. And the trouble with that is that initially they said the ratio of mini to regular is 5 to 2. And then they said the ratio of regular to jumbo is 5 to 4. So when I put these two ratios side by side, you're going to see that it's very useful if I want to convert minis to regulars or regulars to jumbos, but it doesn't help me convert mini muffins to jumbo muffins. So what would be really nice is if I had some consistent metric to use for my regular muffins so that I could say some number of mini muffins is equivalent to some number of jumbo muffins. And that's what they're essentially asking us to do here. So what I'd like to do is re-represent these ratios in such a way that the amount of regular muffins is the same in each ratio. So there are a number of ways to do this, right? I could rewrite this first ratio as 10 to 4. Because if 5 mini muffins converts to 2 regular muffins, well then 10 mini muffins has to convert to 4 regular muffins. That's proportional. Another way to do it is I could call this 15 mini muffins if I were to compare that to 6 regular muffins. And I can go on and on and on with this. I could do the same thing over here where I can convert the ratio of regular to jumbo to 10 to 8 if I'd like to, or 15 to 12 if I'd like to, and I can just keep this pattern going. So I want to do this until I end up with two ratios, one in this column, one in this column, where the number of regular muffins is the exact same. So if I keep this going here on the left, 20 to 8, 25 to 10, you'll see this is where we find that we actually do have two ratios, where now I have a ratio that says 25 mini muffins is the same as 10 regular muffins, and that same 10 regular muffins is the same as 8 jumbo muffins. So what I could actually do here is I could write a proportion that says 25 minis compared to 10 regulars is compared to 8 jumbos. And they are all now able to be compared to each other all at the same time. So if I want to know what the ratio of mini to jumbo is, I just sort of have to ignore that amount of regular in the middle, and I could say that that ratio is 25 to 8. All right, so hopefully that helps you guys if you were stuck on any of those Desmos activity questions.